Hey guys, welcome back to the Beginner's Guide to Restoring Early Black and White Tube Televisions. Now, when we last left off, well, going back a few videos, we did a full power up and we got a partial raster, no sound. Then did a little diversion to the power supply chassis, talked about capacitors, recapped the audio, had a little discussion about a blue glow in the 5Y3 rectifier. Now let's get back to the main chassis and let's actually start working on making this thing get a good image. Now, before we dive right into troubleshooting, I'm going to follow some good advice I was given by a seasoned veteran restorer years ago, and that is to check the tubes. And by that, I don't necessarily mean taking them out and putting them in a tube tester. I mean review the chassis. Pull each tube out, inspect the tube, clean the tube pins, reinsert. If we have tubes that are bad, if we have the wrong kind of type of tube, if it's not seated good in the properly in the socket, we could be wasting a whole lot of time underneath the chassis. So let's get going with that. Alright, so I'm going to go through and pull every tube out one by one. Let's pluck this guy out. It's a 6AU6, I believe. And I'll notice all these tubes, somewhere inside the tube should be a dark or shiny metallic splotch. That's called a getter. These tubes have a vacuum. They suck the air out of them and pinch it off. That's what this is up top. That's where they had the evacuation tube. They sucked the air out, heated up the glass, and sealed it off. Inevitably, there'll be a few molecules of air floating around inside. The getter gets them out of the way. It'll be a reactive metal, think sodium, potassium, something like that, that is very reactive and will attract those air molecules and produce a harder vacuum. Air molecules in between the elements in the tube compromise its functioning. Now, if this had a problem, perhaps a pin was stressed too much and it broke the metal glass seal, or there was a stress crack in the glass, air gets inside, this will turn milky white. So if any of these tubes have a milky white area, they're bad. If you see a hairline crack in the glass anywhere, it's bad. If the pins are corroded, sometimes it'll be greenish. Toothbrush or brass wire brush, I would not use steel, that might be a little too aggressive. Go around, clean them off. Perhaps spray a little bit of deoxit on it and use a Q-tip to get the excess out. And reinsert, maybe taking it out a few times to make sure it's really making good contact, really seated well. So we're going to go through that, do that for all the tubes. Also examine our plug. This looks pretty good, but same deal, we could use a wire brush on that and clean it. Look for any broken off frayed leads, and finally the same for our audio RCA connector. Once all that's done, to my satisfaction, we'll try powering this up again, and then see if we get a crackle out of the speaker. Alright. Cleaned, wiggled, reinstalled the tubes. Now we are getting something out of the speaker. That's what I was expecting to hear before. There's more like it. So just by doing something as simple as examining, cleaning the tubes, I saved myself some troubleshooting time. Okay, where do we want to go next? Let's try injecting a signal and see if we can actually receive anything. I'm going to throw on a temporary knob here so I can turn the channel clunker, which does work. Now this you can only do, since we no longer have terrestrial analog broadcasts, if you have some form of test pattern generator. I have a fancy VG91, which is nice, and you can find some bargains on eBay if you hunt around, but it's not, it's a bit more than we really need. If you have an over-the-air converter box, There's plenty of used ones out there. You get one for $10. Meaning you're going to receive an over-the-air digital signal with an antenna like this, and it goes into a box, and the output is something that can go right into this set. Now, we do have one problem with this set. This is our antenna terminals coming in. It's 2 screw terminals. The twin lead's broken off. It's only attached on one side. I've rigged up this little sort of universal adapter. It has these clippy things that were, I think, made by GC Electronics. These are spaced apart so that they can actually clip onto the screw terminals on the back of a set. And then you have a variety of connectors, your spade terminal, screw terminal to feed a signal into it. I attached a balance, so I can put a 75 ohm source into this, 75 to 300 transformer, or I just have some good old alligator clips on this too I could hook up, so I'm going to use those and clip it onto the stump that's broken off and clip one onto the other side, and then the 75 ohm end is going to go to my generator. A little loose there. Time to get some new cabling. I just compressed it a little bit. It's holding on. Alright, so I'm broadcasting on channel 3 max power. Let's see what the set can do. If anything. All this early stage stuff, this is all me kind of feeling this set out to see where there's problems. Because if we can get, we already know we can get some on the screen. So, it sounds a little funky and it's compressed. And we get some out of the speaker, which means we can use this as a form of an oscilloscope, just like you can when you work on a radio. The speaker, you can hear sound, you can hear if it's distorted, garbled, and you can hear that improve as you work on it. Same with this. So I say if you're lucky and use your smarts and use your multimeter and some common sense, you can get by pretty far without much test equipment. Ooh. The problem is I don't know exactly where channel 3 is. It's attached. You have to wiggle things a little bit. Oop. Oh, I see something on the screen. This tube, this is the oscillator mixer tube. It's flaky. I gotta get that back out, and I might want to just replace that tube because if things are working, whether you have a test pattern generator or not, you should be able to see snow, which is just noise out of the ether that we're pulling down. So even with nothing being injected, you should see something, and it should change as you do this. With just, no matter where you are, no matter what you're feeding into it, or with nothing fed in, when you change channels, it should do something. You hear some kind of, at least some clicking and crackling as you change channels, because there's a bunch of switch contacts in here that are making or breaking contact. Ha 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 ha. For that is our test signal. We can verify that because it can either do the 1 kilohertz or 300 hertz, so we should hear a tone change. Yep, there's 1, it can do 3. Awesome. This should be a window inside a box pattern. There's a crosshatch pattern. Obviously we don't have a crosshatch pattern. Turn it down. Far left we have horizontal and vertical sync. I forget which is which. So let's see if we can get anything to lock. Kinda, almost. This is horizontal hold. And I'm thinking this is vertical. Yeah, it's got to be vertical. So as I was saying, I've said several times now, the vertical is usually the first thing to go on these sets. And really it looks like the sink isn't working for the horizontal or vertical. I was just reminded that I need to warn you guys about something. I've mentioned that vertical problems are very common. Ours is reduced. An even more common issue is that there is no vertical deflection. You have a thin, bright, horizontal line. Do not run your set like that. It will quickly, permanently damage the phosphor, and there will be a visible line there, even when the set's turned off. And also while it's playing, you will see that line forevermore. Do not run your set like that. Turn it off, or at the very least turn the brightness down such that you can just barely see it. Another potential issue is that it's just collapsed to a dot. That's less common though, but it's possible. You definitely want to turn that off because all that energy is concentrated at such a small point. It very quickly can damage the surface of the phosphor. Now on to some practical considerations. We're going to be tipping this chassis on its side, moving stuff around, probing, working on stuff. I do not want to have my very difficult to replace speaker flopping around while we're doing that. So I disconnected it and put it aside. However, we cannot run the set like this because it needs the field coil on the speaker to complete power supply circuit. What we're going to do is substitute for the field coil with a power resistor. Measured about 700 ohms, I'm going to use a 1000 ohm power resistor. Why? Because a filter choke has reactance. We've got 60 hertz ripple going through this. These are more effective than a power resistor at reducing that. Capacitors resist a change in voltage. Inductors resist a change in current. Resistors don't particularly do either one, but it'll do since we have a pi filter, so we have a cap on either side, and putting a resistor in the middle is not as good as a filter choke, but it'll still have some effect. However, it does not have that reactance. Reactance is resistance that's affected by the frequency. A resistor is a constant resistance. We're going to up the resistance a little bit, therefore. So I figure going from 700 to 1000 seems reasonable. I'll see what I've got. Probably 10 watts is appropriate. I think it goes into the two smaller holes. I'll have to double check that. Looks like those are the same diameter as an octal tube pin, maybe. In which case, maybe not quite, maybe. If it was, I saved dead tubes to bust the pins off to make up little things like this. I'll find something, maybe some Molex pins. If I can't find anything that will fit into these, I can tack the resistor underneath. Just be aware, I'm probably going to get a little bit warm. We may need to place it carefully so it doesn't roast something. Running it without the speaker, not the greatest idea for that either. We can throw in an 8 ohm or a 10 ohm resistor on the other side as well. This is the audio output transformer. If you don't have any load in audio output transformer, it goes from a high impedance to a low impedance. You can potentially, I guess, get some transients in here that could maybe damage the insulation on the windings. I'm not entirely sure about that. I've been told it's not a good idea to run an amp without a speaker attached to it. So let's rig up some dummy loads, and then we can push this off to the side. And I want to flip this up and get a scope on the vertical oscillator, and let's compare some waveforms to what the service info shows, and also some DC voltages. I dug up some Molex pins that were the right diameter for that socket. I put a 10K, I dug up some Molex pins that were the right diameter for the socket. On two of them I installed a 1K 10 watt vitreous enamel power resistor, and on the other two I put a 10 ohm 2 watt resistor. That should do fine to substitute for the speaker voice coil. Put a little bit of heat shrink tubing around them as well, just in case anything will bump into anything. Alright, so that takes care of that. I also went over to my computer and printed out some of the rider service info because this has the scope waveforms. Now this is a treat. This is even better than I realized. I also printed out the tube locator, the theory on the oscillators, or at least the block diagram description, so we can look at that. Now this, and also the voltage data for all the tube sockets. Now what's really unusual in a treat, I didn't realize it was this detailed, is this. A dedicated section on waveform analysis. You will not find this in most service info. If they have any waveforms at all, it won't be as this detailed. The question I'm often asked is, where do you hook up the scope? This tells you. They label test point 1, 2, 3, 4, 5. For example, test point 1 is pin 1 of pin 1 of tube V306. Awesome. If you put your scope on test point 1, you should see that. Very, very cool. So, I thought we would have to hunt around and look at our waveforms to figure out where to hook it up and jump around, but no. We know exactly where to hook up for each stage and what waveforms will look like. So if we go down and go to, I think it's the very last page of the service info, they have input to vertical oscillator, output of vertical oscillator, plate of vertical output, vertical pulse. This is stuff we want to look at. We want to look at TP10, 11, 12 and see what's going on. Now, keep in mind, this is near the dawn of oscilloscopes. I think they came out in the 30s, but they're not all commonplace. This is printed in 49 maybe. That's why you just see a waveform. There's no grid, there's no precise on-screen display telling you the voltage peak to peak and the frequency and all that. You just get an overall sense of what the waveform should look like, and then down below they say it's 0.3 volts peak to peak. There's no frequency info because they just assume that you know that the vertical is going to be 30 hertz, that the horizontal is going to be 1575. They're assuming that you're on frequency. This is just, you should see a waveform that looks something like this, that has that peak to peak amplitude. That's all the info they give you, but even that is great because it's more than you usually get. So we're going to do a few things. First, we're going to check the DC voltage on those vertical tubes. Let's look at that circuit. Switch the Wallace Telliade for that. It's way over on the left here. Zoom in a little bit. We're talking about this. 6SN7 dual triode is a vertical oscillator, and 6K6 beam power tube is a vertical output. This, the vertical integrator, the thing that was rebuilt, that has to do with syncing to the incoming pole signal. We can ignore sync for now. Forget about, we're not even going to put an input signal on it. These oscillators are designed to run on their own. With no input signal, it should still fill the screen. They're self-running oscillators. So we care more about this stuff. Haven't even tried the controls. We can try, of course, changing the height control. And we want to check the voltages on, for example, the plate of the vertical output tube, which sometimes you might want to avoid. Sometimes it'll spell out, don't check that point. Because of inductive kickback, you can get some pretty nasty pulses that could kill your scope, like a 1,000-volt spike. But in this case, they don't. So I think we're okay. But at least we're going to measure DC voltage. My multimeter can handle that just fine. So a few reasons why we might have decreased vertical deflection. The voltage could be low. That's an easy one. Or the amplitudes of the waveforms are low. Why might that be? Well, we've got some paper caps in here. If these paper caps are deteriorated and leaky, they can drag down, they can degrade that oscillator waveform. Let's take a look again at the... So there's 60 volts peak to peak on the output of the vertical oscillator. Maybe it's only 30 volts peak to peak. And that could be because we've got leaky caps. Or resistors have drifted off value. And it's not at its optimal bias point on the tube. Or the tube is weak. Those are the three most likely things that pop into my mind. There is one other possibility. Off this height control, we have a 56K resistor that goes shooting off to the right. It goes down and it goes over and 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 over. And it actually goes up into this point. That's what they call a boost voltage, which is really common in these early sets. Sometimes, even with our beefier power supply with 350 volts, that's not quite enough oomph to get the vertical deflection full height. They need a little bit more voltage. 400 volts is typical, 410, 450, somewhere in that ballpark. They get it by stealing a little bit of voltage from the high voltage horizontal deflection circuit. So off of this, they have a little cap here going to ground. It filters out the higher frequency, so you don't need that much of a cap, not much of current draw, and it goes off that way. If this circuit is not operating optimally, that boost voltage could be low, so it's something else to check. Alright, I have the set running on its side. You're going to get used to seeing it like this, because we're going to be doing this a lot while we're poking around. Now here's our reduced raster. Now here's a curious thing. There's a height control on the back. I'm adjusting it, so height goes down, increasing the height. Notice it's not going down, it's just going this way. Potentially, we could have a bad yoke and half of it's not working. That would stink. But let's not get to go there yet. Let's check on other stuff first. I don't think I've ever found a bad yoke. Not an early black and white TV, that's why I'm not that inclined. Could also have a bad vertical output transformer. That's potentially a little more common, but let's check everything else first.